Good morning, my dear friends. Welcome back to my YouTube channel, Coding with Vinod. Today I am going to solve a lead code problem. Problem is maximum count of positive integers and negative integers. We should count the maximum count of either positive integers or negative integers in an array. Given, let us see problem statement. Given an array nums sorted in non-decreasing order, return the maximum between the number of positive integers and the number of negative integers. Vinod, you have previously said that if we find that count in a problem, we should use hash map. Should use hash map. Keyword is count. Here we can use hash map also, but it gives time limit exceeds because hash map uses O of n complexity of time because we should iterate through the complete array. Iterate through complete array. Through array. Iterate through the array. So time limit exceeds O of n. Let us see the statement. In other words, if the number of positive integers be positive and number of negative numbers is negative, then we should return the maximum positive number. Note that this is important. Note that 0 is neither positive nor negative. We can use hash map. If we traversal through an array and inserting into the hash map, then we can get the number of positive numbers, count of positive numbers and count of negative numbers. Then we return the maximum count between positive numbers and negative numbers. If we return this positive count or negative count maximum, then the answer will be correct. Now, given constraint that we should solve the problem using O of log n. Solve the problem using O of log n, and nums are in the non-descending order. Remember, it is hashtag Vinod strict to solve this problem is if in a problem statement, if they say ascending order, if the given nums are in ascending order and the time complexity taken is O of log n, we solve using binary search. Binary search. I think all of you know about what is binary search. It is my trick to solve this problem. How I solve this problem is using my trick. If they are given keywords like non-descending order and if the time complexity is log n, I use binary search. Let us see what is binary search. First of all, if given a number 1, 2, 3, 4, 5, 6, 7. Key is we should find the target as 3. Now, in binary search, the numbers in the array should be increasing order. In increasing order, yes, it is in the increasing order. Now we initialize start as 0 and end as 6. 0, 1, 2, 3, 4, 5, 6, and as 6. Now we calculate the mid value. Mid is equal to s plus e by 2, or for complexity, for higher optimal or lower time complexity, s is equal to e. Mid is equal to s plus e minus s by 2. These are the formulas to calculate the mid value. It is the formula to calculate the mid value. We calculate the mid value. Mid is equal to 6 plus 0 by 2. 6 plus 0 by 2, that is equal to 3. This is the mid element. We check if the mid element let's suppose this is the array. Let's check the mid element is equal to target element. If mid element is greater than, if mid element is array of mid, condition one is if array of mid is greater than target, if array of mid is greater than target, we search the element in this array. So end is equal to s mid minus 1. Second is else start is equal to mid plus 1. If array of mid is less than target, then we search in this array. This is the algorithm for solving using binary search. Let's see how this binary search is useful to solve today's problem. Let's suppose given example is -2 -1. Given array is equal to -2 -1 -1 1 2 3. We should count the number of positive elements and number of negative elements and return the maximum of the positive and negative elements. So what is the approach to solve this problem is first step is we find out the first positive number. First positive number. Next step is we find out the last negative number. Last negative number. If we find out where the position of the first positive number and if we find out the last negative number, then we calculate the count, positive count. Then we calculate the positive count and negative count. We calculate the negative count. We calculate the positive count and we calculate the negative count. This is the third step. We return positive count, maximum of positive comma negative count. We written positive comma negative count. This is the approach. This is the approach to solve this problem. Then let us see example how we calculate the first negative number, first positive number and the last negative number. 1, 2, 3. Initially start is equal to 0. Start is equal to 0. Start is equal to 0. End is equal to n minus 1. End is equal to n minus 1. Now, start is equal to this and end is equal to this. Now, we initialize start and end at the first step. Now, we calculate mid value. We calculate the mid value. Mid value are 0, 1, 2, 3, 4, 5. Mid value is 5 plus 0 by 2. Previously, I have said how to calculate the mid. That is 2.5. We calculate the int. We store it in the form of int. So decimal part will be gone. It stores only 2. Mid is this. Mid is this. Now, what is the condition to submerge this subarrays? That is, it is divide and conquer rule. We divide the array into the smaller parts and we solve this. We have calculated the mid. Now, coming to the next point, now where should be the start lies and where should be the end lies is if array of mid is greater than 0. If array of mid is greater than 0. We calculating the positive number. First step is positive number. First positive number. If array of, suppose 1 is the positive number, we keep start to the mid plus 1. We keep start with the mid plus 1. Now we should calculate the mid as positive number. We should calculate mid as positive number. So end is equal to mid minus 1. Else start is equal to mid plus 1. Here we get the positive numbers. Here we get positive numbers. If we want to calculate the positive count, subtract n with starting or ending. Positive count is equal to n minus s, because s is pointing to the index value. S is pointing to the index value. Let's see how this we can get the positive count. Mid is equal to this. Array of mid is less than 0. So start will goes to here. Start goes to here. Now we calculate the mid for this value. Mid for this value. Mid is equal to mid points to fourth element. Mid points to the fourth element. Now array of mid is greater than 0. So end is equal to mid minus 1. End is here. End points to here. Now start and end are at the same point. So mid also points to the same point. Array of mid is greater than 0. So end is equal to mid minus 1. End is equal to mid minus 1. End is equal to. From up to where we should solve this binary search is, there is a condition where S should be less than or equal to E. S should be less than or equal to E to calculate the binary search, because it is in the increasing order. If suppose the increasing order gets mismatched, that is, if we want to search 1, 2, 3, 4, 5, if the target is 3, 4, if start is here and end is here, we get the conditions where it gets false. These conditions would get false. These conditions would get false. So we should iterate through the element where S should be less than or equal to E. Now we have got the positive count. Positive count is, we have got the positive count. Now we calculate the negative count. Similarly, we start the index element. Let's suppose array is equal to -2, -1, -1, 1, 2, 3. Start element is equal to 0. End element is this. 0, 1, 2, 3, 4, 5. Start element is this and end element is this. We calculate the here. Let's see how the condition would be applied. If array of mid is less than 0, we have got the element. If array of mid is less than 0, we are trying to the negative number, and the negative number is, we have got the first negative number. So start is equal to mid plus 1. We iterate to the next array. Up to this, we have got, suppose it is the mid number. Up to this, we have got it is the negative number. We should search in this range. We should search in this range. So we increment the start to divide this array up to the mid, and we calculate the mid element in this range. Else, suppose if it is not in the range, we should search the element in the before elements only. That is, we should search the elements in this range only. So see, listen my dear friends, in this condition states that if array of mid is less than 0, that means this element, we have got this element as, suppose this element mid is less than 0, we have got the number negative number. check for this range. Check for this range. Next, if we haven't got this, suppose this is the mid element. Suppose this is the mid element. We haven't got, it is positive number. So we should search in this range elements. I hope this binary search is all clear to all of them. Let us see let us code this algorithm. Let us code this algorithm. Let's go step by step how we should approach to this problem. Initially, we keep n as nums dot length. Initially, n dot int. Starting is equal to 0, int. Ending is equal to int. Ending is equal to n minus 1. We should initialize starting as 0 and ending as n minus 1. Now, we calculate the positive number. We calculate the positive number while s is less than or equal to e. While s is less than or equal to e. If start or calculate the mid element, into mid is equal to start plus ending by 2. Start plus ending by 2. If array of mid is greater than 0, that means positive numbers have reached. Positive numbers have reached. We should suppose this is an array, positive element is reached here. We should search in this range element. So we decrement we decrement the end value to mid minus 1. End value to mid minus 1. So else we increase, still the element is the negative number. So we move the subarray to the this element. Subarray to the these elements. So else is equal to start is equal to mid plus 1. We increment the start is equal to mid plus 1. Here we will get the last first index positive number. First index positive number. So int positive count is equal to int positive count is equal to n minus end. N minus n. Positive count is equal to n minus n. Now we calculate the last negative number. Last int last negative number. Similarly, same we copy this and paste this, but we change it to some conditions. As here if array of mid is less than 0, if array of mid is less than 0, array of mid is less than 0, s is equal to mid plus 1. S is equal to mid plus 1. We have got the last element, end is equal to mid minus 1. I have already discussed what is the condition, how this condition reaches. We calculate the negative count. Negative count is equal to negative count. Negative count is equal to negative count is equal to end plus 1. We should return math of negative count comma positive count. We would return positive count and let's see whether this problem is accepted or not. It is accepted, my dear friends. I think code is clear to all and the problem how to approach this using binary search and this remember this trick, my dear friends. It is more important. And this also one trick to solve the problems and binary search, how to go to approach solve solution using binary search is all clear to all. Thank you, my dear friends. Please subscribe to my YouTube channel and I hope all are clear about how the problems are solved using various tricks and various approaches. Let us meet again on the next day with a beautiful solution on the. Thank you, my dear friends.